Hello and welcome in a new video. Let's solve application 2.3. In the figure below, two blocks of weight W1 and W2 are superimposed on a horizontal plane. The coefficient of friction between W1 and W2 is mu1, and that between W2 and the plane is mu2. So we have two blocks. We have the block designated by W2 and we have the block designated by its weight W1. They are superimposed on a horizontal plane. We have mainly two surfaces, the surface of contact between W2 and the plane. This surface has a coefficient of friction mu2, and we have another surface which is the surface of contact between W1 and W2, and here we have the coefficient of friction mu1. We exert a force F on W1 at an angle alpha to the horizontal as shown in the figure. So we apply a force F. It makes an angle alpha with the horizontal axis. If cotangent alpha is greater than or equal to mu1 greater than or equal to mu2, demonstrate that the necessary and sufficient condition for W2 to move relative to the plane without W1 moving relative to W2 is as follows. So we have here two inequalities. So they want us to find that F is smaller than a certain quantity and that F is greater than another quantity. So these inequations are necessary and sufficient for what? So that W2 moves on the plane relative to an observer on the plane without W1 moving on its own, so relative to W2. So let's start. We have to demonstrate these two inequalities. So we need to find two inequalities showing F greater than a certain quantity and F smaller than another quantity. So we have in fact here three options to apply the fundamental relation of dynamics. We can apply it on W1 alone, we can apply it on W2 alone, and we can apply it on the system formed by the two blocks. So F is applied directly on W1, so it's obvious to choose W1 as the system on which we apply the fundamental relation of dynamics or Newton's second law. Okay, so let's start by considering the system of the two blocks. Now we consider the system of the two blocks as a whole system. We draw here the free body diagram. So what are the forces acting on W1 and W2? We have weight, the weight of the two blocks, W1 and W2. We have also the normal and directed vertically upward. We have the friction on the surface of the plane, so F2, and we have the applied force F forming an angle alpha. So we have W1 plus W2 plus N plus F plus friction F2 equal the mass of the two blocks, so M1 plus M2A. We don't need to find an equation. In fact, we need to find an inequality. So how can we find this inequality? So the key to solve this exercise is by understanding what do we mean by W2 moves relative to the plane. So if W2 can move relative to the plane, this means that the friction on the surface of the plane is small, but it's small relative to what? It's smaller than what? So let's consider all the forces except F2 as sum of F prime, and we will say that for that the system W1 and W2 moves, we need to have that the force F2 is smaller than sum of F prime x, because here in fact we have a conflict between F2 trying to stop the motion and sum of F prime trying to make the motion. So the winner will impact the motion, will have the most important impact on the motion. So since we have the motion of W1 and W2 relative to mu2, this means that F2 is very small. It's smaller than sum of F prime x. So here the winner in this conflict is sum of F prime x. Okay, we need to find what is sum of F prime x, and we need to find what is n, because F2 is equal to mu2 times n. So how do we find sum of F prime x? We need to project W1 plus W2 plus n plus f on the x-axis, and we need to find n. How do we find n? By projecting this equation on the vertical axis y. So let's do these two projections. On x prime x, sum of F prime x will give us, so W1 and W2 and also n don't have any component along x, so their projection gives 0. We have only the component of f along x. So here we consider that the x-axis, the positive x-axis is toward the left, because we respected the convention that we took the positive direction of x as the direction of motion. So since the motion can happen to the left, then positive x, we choose that positive x is to the left. So sum of F prime x is equal to fx, which is equal to f cosine alpha. Okay, so we found what is sum of F prime x. It's equal to f cosine alpha, and we want to make it greater than F2, which is equal to mu to n. So what is n? Let's make a projection along y of what? Of the first equation of the second law of Newton. So we have minus W1 minus W2, because these two vectors are downwards, plus n plus f sine alpha, because f has also a component along the y-axis. And now we want to make the acceleration along y equal 0, because ay is 0. The motion cannot happen vertically. So we only have, if there is motion, the motion is only along the x-axis. It cannot be along the y-axis. That's why ay is equal to 0. So we can deduce what is n. N is equal to W1 plus W2 minus f sine alpha. Let's replace n with W1 plus W2 minus f sine alpha in the first expression, which is this one. This means that F2 is equal to mu2 W1 plus W2 minus f sine alpha, and this gives that f cosine alpha greater than mu2n. So f cosine alpha is greater than mu2 W1 plus W2 minus f sine alpha. Now let's notice that f figures in this term, in f cosine alpha, and it also figures out in this term. Okay, if we go back to the question, they want us to find that f is smaller than a quantity and greater than another quantity. So we need to isolate f. Let's take f as a common factor. And so we will find that f is greater than mu2 w1 plus w2 over f cosine alpha plus mu2 sine alpha. And this is the first inequality that we want to prove. So f is greater than this quantity. Now we still need to prove the second inequality. So as I said, that we need to apply Newton's second law on another system to find that f is smaller than this quantity. So we have two options. We can apply Newton's second law on W2, but for W2, if you apply Newton's second law on W2, you will not have an equation or any inequality showing f or including f. That's why we have to use another system. So the other system that we need to use is the system, the block W1. So if we apply Newton's second law on W1, we can see that. So here again we draw the free body diagram showing W1 as a point. We have W1, we have N1, we have F and friction, but now the friction happens on the surface of contact between W1 and W2, where we have F1. So we apply the fundamental relation of dynamics on W1 and we found this equation. And once again, we want to prove an inequality. So the inequality here can be found if we say that the system, which is W1, cannot move relative to W2. So here we have a conflict, once again, between the friction and all the other forces. The winner will have the most important impact on the motion. So here we have a conflict between F1 and sum of F double prime. So here, since W1 cannot move on W2 relative to W2, this means that the winner is F1. F1 is greater than sum of F double prime x. So here we want to find what is sum of F double prime x, and we need to find what is N1. Let's make two projections, one along x to find sum of F double prime x, and another projection on y to find what is N1. So along x, sum of F double prime x is equal to F cosine alpha, and F cosine alpha should be smaller than F1. Now the projection on the y-axis will give us minus W1 plus N1 plus F sine alpha is equal to M1 times AY, and AY is equal to 0. So we have F sine alpha minus W1 plus N1 equals 0. We need to find N1, so N1 is equal to W1 minus F sine alpha. And this will give us that F cosine alpha is smaller than F1, so smaller than mu1 N1. And here again, we notice that F figures out in this term and in this term, so we take it as a common factor and we isolate it. So F, we can find easily that F is smaller than mu1 W1 over cosine alpha plus mu1 sine alpha. And this is the second inequality that we have to prove. Please notice that the term cosine alpha plus mu1 sine alpha should be here positive, and also the denominator in the previous slide here, this term should be also positive. So finally, we have found that f is smaller than mu1 w1 over cosine alpha plus mu1 sine alpha by considering the system w1 and applying Newton's second law on it. And we have also found the other inequality, f greater than mu2 w1 plus w2 over cosine alpha plus mu2 sine alpha by considering the system of the two blocks.